Oh boy, here it is. The coolest sounding section in the entire course, machine learning. Now, throughout the course, we've learned that machines are really good at certain things. Machines can perform tasks really fast. And we learned through Python that we can control these machines and get them to do tasks for us. Now, these machines or computers are really good at things that we can describe, right? That we can write in code. If-else blocks to do something. Computers are really good at working on tasks that have these defined rules. All the way up to a game of chess, right? When you play a game of chess against a computer, we could technically have if-else blocks, lots of them, to see how to move each piece and what the pros and cons are. But then as soon as we stop having these specific rules, things start to break down. For example, what is a cat? If you could describe that to a computer or you had to program in Python and try to write that code in Python, would you be able to? I mean, sure, you can say, hey, a cat has fur, a cat has whiskers, a cat meows. But then the computer asks you back, what is a meow? What is fur? The harder things become to describe, the harder it is for us to tell machines what to do. In this section, we're going to tackle this problem. And we tackle this problem using something called machine learning. And you've definitely heard of it because it is a big buzzword right now in our industry. Because with machine learning, you have so many applications. We could have self-driving cars, robots, vision processing, language processing, recommendation engines, translations, stock price predictions. There's so many applications. The goal of machine learning is to make machines act more and more like humans. Because the smarter they get, the more they help us humans accomplish our goals. Now in this section, we're going to go over some theory to get us familiar with this topic and then do 3 projects on both data science and machine learning to understand this topic a little bit more. Don't worry, don't get intimidated. We're going to try and simplify things and have fun along the way. Let's get started. Now, up to this point in the course, we've talked about Python careers, and we've talked about being a backend developer using Python, about testing and automation, about being a general Python developer and doing scripting, being a software engineer and just writing software using Python. But we haven't really touched on the subject of machine learning or research analyst, data scientist, data analyst. And you see, all these fields kind of overlap. So what is machine learning? When we talk about machine learning, you have to keep this diagram in mind. You see, it all starts with AI, or artificial intelligence, which simply means human intelligence exhibited by machines. An AI is, well, a machine that acts like a human. And currently, in our industry, we have something called narrow AI. That is, machines can be just as good or even better than humans at a specific task. For example, detecting heart disease from images, or at the game of Go, or even video games. But narrow AI that we have currently simply means those machines can only do one thing really well. They can't be like humans and have multiple abilities. That's called general AI, and it's something that we're very far away from. Now, machine learning is a subset of AI. And machine learning is an approach to try and achieve artificial intelligence through systems that can find patterns in a set of data. And actually, Stanford University describes machine learning as the science of getting computers to act without being explicitly programmed. That is, getting machines to do things without us specifically saying, do this, then do that, then do this. And don't worry, we'll explore that more throughout this section. Now, you may have also heard of deep learning. And deep learning, or deep neural networks, is just one of the techniques for implementing machine learning. For now, you can just think of it as a type of algorithm. But then we have this thing of data science. And often the role of a data science and a machine learning expert are quite overlapping. And most job descriptions actually don't even have a clear distinction between what is a machine learning expert and a data science expert. The field of data science simply means analyzing data, looking at data and then doing something with it, usually some sort of a business goal. So when we talk about machine learning, there's a lot of overlap with data science. So throughout the next couple of videos, we're going to be talking about both of these topics because both of them relate and overlap. And you can't do one without the other because you need to be able to understand data and work with data to do any of these things. And that's why when we talk about careers, often things like machine learning, data scientist, data analyst, or research analyst are similar because they all work with data. And from that data, they want to derive some sort of an action for the business, for the company, or for the person. All right, that's enough for now. Let's move on to the next video. All right, I know what you're thinking. You're thinking, Andre, I have no idea what you're talking about. What is machine learning? You haven't really told me anything. I have nothing to apply it to. Well, let's go back to this topic of machines and computers and the fact that they don't really understand words, right? If I ask my computer, hey, is this a snake? Is this a python? My computer is going to, have no idea what I'm talking about. When I look at an image of a snake, no matter what color it is, no matter whether it's a cartoon or a real life image, or whether it has different directions with different animals in it, I can identify a snake right away. Our brains just know. But to tell my computer what a snake is almost impossible, right? Because there's so many factors. A snake doesn't have legs and arms, but an airplane doesn't have legs and arms. A snake has scales, but then the computer is going to ask me, what are scales? But with machine learning, we can actually teach a computer to know what a snake is, or at least pretend like it knows. So how do we do this? Well, you remember this diagram, I hope. It's simply what we do in programming. That is, we give an input, let's say a list of 1, 2, 3. We give it to a function, and there's an output of 2, 4, 6. So clearly this function multiplies our list, items in our list, by 2. And often our programs are procedural. That is, we have if this, then that, do this, then this type of conditions. We tell the computer what to do. We write as programmers the input and the function. And all the computer does is actually just calculate using the input and the function, the output. And it can do that really, really fast for us instead of having a human do something when, let's say, a list is millions of items long. Machine learning changes this idea. It says, hey, give me the input and give me what you want the output to be. That is, give me all the data that you have. And by the way, tell me what the answer is, or at least what the output that you want. So in this case, I want the input to be a list of 1, 2, and 3, and the output to be a list of 2, 4, and 6. And then the interesting part is that as developers, we give this input and output, but with machine learning, we say, hey, machine, you figure out what this function is. Because if I give you, let's say, instead of a list of all these snake pictures or maybe animals, and I want you to tell me if this image has a snake or not, or maybe these 100 images, which one of them have snakes? Well, I don't know how to tell you how to do that So instead, you figure it out yourself. Here are all the pictures, and here is what I expect the output to be, either snake or not snake. And with machine learning, the function is generated or created by the machine. Sounds really cool, doesn't it? And this is machine learning. It's simply a function. So instead of us writing the function like we have before, with machine learning, the machine writes the function. We just give it the input and the output. And the word function can be replaced with a model. You might have heard of the word machine learning model. That's all a model is. It's a function that receives an input and returns an output. Another word might be algorithm, a machine learning algorithm, a machine learning bot. And at the end of the day, it's a brain. We're pretending that this machine is a brain that understands the inputs and gives us the desired output. Now, the interesting side effect of this is that often when we talk about machine learning models, these functions are really hard to understand. Because the computer comes up with this function, as a human, it's hard to really understand how it works. And as these models get more and more complex, it becomes harder and harder for us as developers to understand how it works, which raises a lot of issues. But we don't need to get into that. Now, as you can see, the main part of this is that in order to train this machine to create this function, we have to give it data. And for it to be really, really good, we have to give it lots and lots of data. And then we want to test to make sure that this data that we give in gives us the correct output. So at the end of the day, machine learning is simply a computer writing its own function based on the inputs and outputs. That's pretty cool, isn't it? I'll see you in the next video. Bye-bye. One thing that I really like doing in my courses is to actually understand the why of everything. Everything that we learn, there should be a reason we're learning it, right? And you might be asking yourself, why do we even care about machine learning? How is that useful and how do we get here? Well, if you think about a business, because most technology evolves from business needs. We have the advent of computers and the ability for businesses to use computers to do things really, really fast and efficiently so that they gain an edge. And then we got spreadsheets. Spreadsheets like Excel files and CSV files were amazing because we can store data that businesses generate, such as maybe customer data, into an Excel file. And then people got really, really good at analyzing these CSV files, these spreadsheets, to make business decisions. Maybe forecasting that December sales are going to be high because, well, the past 2 years we've had really high December sales because of Christmas. And then as companies got more and more data, we started getting this idea of relational databases. Spreadsheets were great, CSV files were great, but we started getting more and more information and data, and we needed a better way to organize things, to understand things from our data. That's when we got things like MySQL, which allowed us, instead of using spreadsheets, to use a language called SQL to read information from our database, write information to our database, but similar to spreadsheets, use the data that we gathered from the business to make business decisions so that our business becomes even more profitable. And then in 2000s, we had this fancy term of big data. We had big companies like Facebook, Amazon, Twitter, Google that started accumulating more and more data. An insane amount of data that you simply couldn't contain in a spreadsheet. User actions, user likes, user purchasing histories. This idea of big data meant that we had so much data. These companies had so much data. And sometimes, unlike relational databases, which had to be a structured form of data, sometimes we got really messy, unstructured data. And that's when we started getting this idea of NoSQL, where things like MongoDB came into existence, where you can store unstructured data and hopefully make business decisions out of that. Maybe if you were Amazon, you can use customers' purchasing history to recommend different products. And ever since then, this idea of data, getting more and more data, has turned us into using machine learning. Because at some point, we have so much data that as humans, we can't just look like we did at spreadsheets and look at columns and rows and make business decisions. I mean, we still could, but then we'd be wasting all this data that we've been getting over the years. So companies like Facebook and Google that collect massive amounts of data every single day are turning to things like machine learning, so that instead of humans looking at the data and trying to figure things out, we give this data to machines so that they're better able, even better than humans, to make business decisions. And this idea of machine learning really came to be because of this growth in data that we received from businesses, as well as the improvements in CPUs, GPUs, that is graphical processing units, and computer advancements. So using the massive amounts of data and massive improvements in computation, we can use these machines to give them this big data and make decision for us, just like we used to with spreadsheets. Now, this is a simplified version of how we got here, but I hope it gives you a reason as to why businesses like this idea of machine learning. I'll see you in the next video. Bye-bye. Welcome back. Up until now, I've been blabbering on about what machine learning is, and I hope you have a bit of an idea of why we have it and why it's useful. But at the end of the day, the only reason that we care about machine learning is that we're able to use machines to predict results based on incoming data. That's it. Now, this idea of machine learning, and don't worry, I know we keep talking about theory, but I promise we're going to get some coding exercises first. But I do want to talk quickly about some of the machine learning categories that you often see. And keep in mind what I said. That is, machine learning is simply about predicting results based on incoming data. And all these subcategories simply do that. For example, we have the idea of a supervised learning, which is a subset of machine learning. In this supervised learning, the data that we received already has categories. Think of it as a CSV files with rows and columns labeled. We have labeled data and a test data that is labeled so we know if our function is right or wrong. So in a supervised learning scenario, we can do things like classification to decide, is this an apple or is this a pear? Machine learning model simply draws a line to decide, hey, this is an apple and this is a pear. Or we might do something called regression instead of classification, based on inputs. For example, predicting stock prices. Another way that we might use supervised learning is, for example, to hire engineers based on inputs, based on years of experience, based on maybe age, maybe where they live, what type of computers they have. All these sorts of inputs that are labeled can be used in a supervised learning system to decide, should I hire this engineer or should I not? Now, sometimes we have data that doesn't have labels, and this is called unsupervised learning. Again, think of it as a CSV file without perhaps the column names labeled. Sometimes with things like clustering, we need to create these groups, or at least the machine to create these groups. For example, we give it a bunch of data points and then the machine decides, oh, this is a group, this is a group, and this is a group. Or we can have something like association rule learning, where we associate different things to predict what a customer perhaps might buy in the future. When groups don't exist, we call it unsupervised learning, We can't tell the machine that they are right or wrong like we can when we do apples versus pears, since there are no true categories, but we let the machines just create these categories for us. Finally, we have this idea of reinforcement learning. And reinforcement learning is really interesting because it's all about teaching machines through trial and error, through rewards and punishment. So the program simply learns a game by playing it millions of times until, well, it gets the highest score. It doesn't know what it's doing at first, but then it tries to maximize the score and eventually figures out that, hey, maybe I should try and move where the ball is coming. So this is seen for skill acquisition or real-time learning. And you see it a lot in machine learning programs that play, for example, video games. Now, I'll link to a resource so that you can dive into these topics more deeply. And we'll actually talk about this a little bit more and understand them a lot better once we go through some of the exercises. But the idea here is that machine learning has different categories and different ways to accomplish its goal. And topics like neural networks, decision trees, support vector machines, k-nearest neighbor, are simply algorithms that are used with these subfields in order to come to these predictions. But remember the key thing. All of these, what they're doing is trying to learn from the data that it receives and predict something. I'll see you in the next one. Bye-bye. All right. I think it's time for us to actually start practicing some of these skills instead of just talking about theory. Because I know right now, everything looks super complicated. You think that to be a machine learning expert, you have to have a PhD and you have to be really, really smart with math and statistics. But often that's not really the case. So in this video, I want to show you what it actually means to do machine learning or data science. So in this Machine Learning 101, let's talk about what a machine learning expert does. The first thing that a person does is to usually import the data. That is, we have some sort of a CSV file, and we're going to import that data, and we know how to do that with Python, right? We import a CSV data file so that we can use it in our program. And don't worry, these are the steps that we're actually going to show you when we do our upcoming projects. So the first thing is to import the data. Next, what do? Well, we clean the data. That is, in an ideal world, we have perfect data. All the columns, all the rows of a CSV file are filled in, and everything is perfect. But that's often not the case. Sometimes you have missing labels. Sometimes you have missing cells or data. And sometimes we have just unusable data that's really, really bad. So we ideally clean the data so that when we use it later on, it's not going to give us any errors or make bad predictions. Now, number 3, what does a machine learning expert do? Well, we split the data. And this is an interesting one. We usually split the data into what we call a training set and a test set. What does this mean? Well, splitting the data simply means just deciding we have, let's say, 100 rows of Excel, and we decide that the 80 rows are going to be our training set, what we give the machine to learn from, and then the last 20 rows are going to be the test set, because we have to tell the machine whether it got the answer right or wrong. So we need a way for us to test with our pre-existing data whether our model is good or bad. Again, this is something that we'll explore, but usually you split your data, your Excel sheet, into a training set, what we use as input, and then the test set, what we use to test the output that machine learning function gives us. And that's really easy to do. We just decide, hey, 80% of the data is going to be training set and 20% is the test set. Up until now, these three things are pretty easy, right? And as we'll see, they are quite easy. Next is we create a model. All right, this one sounds really, really hard, right? We just went from splitting data to all of a sudden we're creating this function, this model that our program creates. But the funny thing is that most likely what you do when you create a model is to import an algorithm. You're not going to write the algorithm from scratch yourself. Usually you use a library like scikit-learn, which we're actually going to use to simply do an import and then decide what algorithm you want to use, like decision trees or k-nearest neighbor. And we'll actually see how to do that in an upcoming exercise. So that's really nice. Somebody has already built an algorithm for us that creates the model based on our training set. And the running joke is that when people think about machine learning expert, they think of all these mathematical equations that people do, but most of the time it's people just simply importing from a library an algorithm. That's it, a one-liner. Next, what do you think we do? Well, we check the output, right? We create the model, that is the function. We have the input, which is the training set, and then we check the output of this model with our test set. So the test set, we're going to say, hey, is the output matching what we expected? So once we check the output, what do? Well, we improve. So most likely the first time around, it's not going to get it completely right. So based on the test set, we say, hey, we can probably improve something. So as a machine learning expert, you might give it extra inputs, that is maybe an extra column in the Excel file, or you might want to change the model or the algorithm that you used to create this model. That's it. These are the 6 steps of what you do, and you just repeat these steps. Now we'll come back to these and I'll link to this in the resource so that you can always have it in the back of your mind. But right now, you just learned something really, really fundamental. You see, Facebook here, this is pretty much how they run their machine learning pipeline. And this diagram now should make sense just on those 6 steps that we talked about. We define their goals, that is, what do we want to accomplish? We gather the data. We parse the data, that is, we clean it, we split it into training data and testing data. We then do model creation and we experiment with different algorithms. And then we finally test our data, see how accurate it is based on our testing data. And then we just go back and try different things until our model or our function is in line with what we defined as a goal. Isn't that cool? You just learned how Facebook's machine learning structure works. Now, let me ask you one question before I end this video. What do you think the hardest part of this entire process is? I made it sound very, very easy, right? Think about it. Ready for the answer? The hardest part is actually grabbing the data. Because the more data we have, the better. The more inputs we have, the more training sets we can have, so that we can improve the model. And yes, we can decide what algorithm to use to create a model, what inputs to use during the training set, but the more data we have, the more options we have as machine learning experts. And it's really tough to collect good data, or what we call data set. And companies like Google and Facebook are really, really valuable because they're the only ones that can collect that much data. And that's why machine learning is pioneered by these companies that have large sets of data. Because you and I just simply don't have enough data to really make machine learning worth it. Most companies don't actually need machine learning or can even implement good machine learning because they don't have enough data. You need big companies like Amazon to use machine learning because they're the only ones to have access to that data. And that's why they're so valuable. They can share their model, they don't care, but they usually keep their data private because that's what gives them a competitive advantage. All right, so now we know the steps of machine learning. The next is to learn what tools we can use to do these steps so that we can finally start learning and building our own machine learning models. I'll see you in the next one. Bye-bye. Welcome back. So up until now, we've learned the steps of machine learning, and we learned the theory about machine learning. The last piece of the puzzle is what tools do we use in order to learn about machine learning so that we can finally start doing some exercises and projects. And this is why Python is actually one of the most popular languages when using machine learning. Because Python has such a big community and it's such a easy expressive language, as we've learned, that it has a ton of libraries and modules that really help us do machine learning in a really fast, efficient way. It's not that Python is just the only language that you can do machine learning in. It's that Python has the best tools available currently to do machine learning. So what are these tools? The first one is NumPy. And NumPy is definitely a must when it comes to machine learning. It's a library that helps us to use lists and arrays in Python, and specifically multi-dimensional arrays, which are used very, very often in machine learning. So we're going to be using NumPy. And then the next one is Pandas. And Pandas is used for what we call data analysis. Pandas gives us an idea of this data frame, which allows us the functionality to manipulate data in tabular structure with rows and columns. That is, we get to usually read a CSV file using Pandas. It's going to extract this data into something called data frame, and you can do all these amazing transformations and aggregations using these data frames. And don't worry, I'll show you how to do this in the next video. So we have NumPy for working with lists and arrays, Pandas for usually working with something like tabular data, so CSV files, and then we have scikit-learn. And scikit-learn is that really exciting create a model part, where we import the scikit library, and scikit comes pre-built with, as you can see, different algorithms that we can use. So we can do classification, we can do regressions, we can do clustering, just by importing this library. And then we use something like matplotlib. Now, matplotlib, again, is another library, what we call a charting library. It allows us to visualize data in a nice way. And there's many tools that are built on top of matplotlib that help us visualize data in any different way that we want. Finally, the two last crucial tools that we need is, first of all, Jupyter Notebooks. If you remember, in the developer environment section, we talked about Anaconda and how Anaconda, by installing it, gives us access to the Jupyter Notebooks. And Jupyter Notebooks are really, really useful because up until now, we've written code in PyCharm or Sublime Text or Visual Studio Code. But Jupyter Notebooks are really, really useful when we do machine learning or data science because, as we'll see, it allows us to step through our code and actually output and keep track of all these things that we've been doing, and also see visualizations, something that you can't really do in a text editor like Sublime Text or PyCharm. So you can step through each data analysis stage and have these notebooks visualized and potentially even give to different people in your company so that you can create a story and share it with others. So it's a notebook that allows us to communicate better. And it's a very critical tool that is pretty much standard now in the data science and machine learning field. And as you can see, these are crucial tools in our tool belt that we're going to use throughout the next couple of videos. But all of them work really, really well with Python. And it's why Python has become such a standard in the machine learning community. The final piece of the puzzle, though, is that data, right? When we import the data and clean the data, we talked about the most difficult part being the actual collection of the data. In order for us to learn about machine learning, we actually need some data to work with. Now, we're not Facebook or Amazon or Google or Apple, but there's another useful tool called Kaggle. And Kaggle is a community of machine learning experts where you can do competitions, you can look at other people's Jupyter notebooks, but it also has data sets. That is, we have free access to data, to massive amounts of data that are openly accessible. If you want to learn about crimes in Boston, about the PGA Tour, about gas prices in Brazil, you can actually download for free these data sets so that you can play around with machine learning. And we're going to do just that in the next video. So for now, make sure, if you haven't, get your Jupyter notebooks ready. Again, check the developer environment section where I show you how to set this up, and then create a free account on Kaggle because we're going to start getting our hands dirty with some coding. I'll see you in the next one. Bye-bye. It's time to finally start coding. And in this exercise, we're going to be exploring some data that we're going to grab from Kaggle. It's time to do some coding. So open up your Jupyter notebooks. Now, in my case, I already have some files here, but usually it'll just be whatever files you have on your desktop. It doesn't really matter because we're going to create a new file here and make sure that the notebook is going to be in Python 3. So once you create that notebook, title it whatever you want. In our case, we're going to be exploring some FIFA soccer data sets. So let's just call it soccer. Now, in order for us to learn about data science and machine learning, we remember our steps, right? We have to import the data. So we get the data from what we explored last time, which is Kaggle. If you haven't registered already, make sure you do that. Otherwise, just sign in. And once you're signed in, just go to datasets. Let's make this a little bit bigger. And within the datasets, again, we can pick whatever we want, but I feel like checking out the FIFA 2019 dataset. Now, I usually like looking at the scores here to make sure that it's a good dataset. In this case, it looks like the FIFA 19 complete player dataset is looking pretty nice. We have 2 megabytes of data. It was uploaded 8 months ago, and it's a one file CSV file. So you can actually click on Quick Look here, and it'll show you some other information that you may need. In our case, it's a CSV file, so that's great, but just a heads up, it is a bit of a big data set. So if we click on it, we can just simply click on Download and wait a little bit as your datasets gets downloaded. Now, I want you to unzip this file and put it on your desktop where your Jupyter notebook is. So you want it in the same folder as the soccer notebook that you just created. Let me do that. So now if I go to my home, I see that I have data.csv, which is the file that we imported from Kaggle. As you can see right now, it looks like a massive amount of data. We can't really read it because it's in CSV format. Now, if we go back to our soccer notebook, we're going to use the pandas library to do our data analysis to see what we actually get from Kaggle. Now, in our case, we used Kaggle to grab our data, but you can imagine that there's different ways to gather the data. You can, for example, like we saw, use something like Beautiful Soup to scrape web pages so that you can understand it better. So you can use any type of data possible. Ideally, if it's in a CSV format, then we can use pandas and really do some neat things with it. So let's take a look. Now, luckily for us, by opening Jupyter with Anaconda, remember the Anaconda Navigator, we actually have access to libraries like pandas automatically. So all we have to do is simply say import pandas, and we can do as PD just so we have a shorthand instead of typing out pandas every time. So if I do this, I now have access to pandas. And with pandas, I can do read underscore CSV to actually read our CSV file. And because our CSV file is in the same folder as our soccer notebook, I can just simply give it the string data.csv, which is what we have over here downloaded. So if I run this, I get my data right here. And look at that. I have my pretty data with nationality. We have links to photos. We have the name of the players, the IDs, the age, and a ton of other things. Now, the neat thing with pandas is that we get this output as what we call a data frame. And pandas allows us to manipulate this data frame so that we can do interesting things with it. So usually what you'll see is you'll just create a variable data frame equals pd.readcsv. So that now this data frame is what we get down here. All this information is now in our data frame variable. And we can do interesting things and run different methods and properties on it. So for example, if I do data underscore frame dot shape, it'll give me more information about my data. In this case, you'll see that a tuple object is not callable. I get nice errors in my Jupyter notebook, and that's because shape is actually not a method, but instead a property on data frame. So if I run this again, look at that. This is the shape of my data. I have 89 columns and, well, a ton of rows. Now, I can also do different things. And this is the neat part about Jupyter, is that I can just leave the input and output here. And if I do a different cell block, I'll still have this information. It'll still have imported pandas as PD. So if I do now data frame dot, let's do describe, I'll be able to run this. And again, it shows or describes the data that I have. With describe, we get the count. So for example, the overall age accumulated. We get the mean age, that is the average age of the player, so 25. And we also get interesting things like maybe the oldest player is 45. The highest jersey number is 99. And all this different type of data. Finally, if I do something like data frame dot values and I run this, I get all the values of my data. And you see here that it's an array that has different players in it. So remember how I said libraries like NumPy work with arrays and lists in Python and help us manipulate them? Well, as you can see, our data frame is stored as an array of each individual player that we could potentially manipulate. And what we've done here is we've simply imported the data. So we learned the first step of our ML steps, that is to import the data. We found the data and we used pandas to grab our data into a data frame. Now, there are many different things that you can do with pandas. And I want you to, after this video, I'm going to link to this resource so you can try different methods and properties on your data frames to see what type of things we can do. So I want you to go through this exercise and just try different things. For example, in filtering here, we can try and learn about filtering our data frame. So again, if I just copy and paste this, change this to our variable that we have. So data frame. And then we want to filter, let's look at the shape of our data or see what type of data we have. You know what? Let's filter by age. So I'm going to say data frame. We're going to go by age. And I'm going to say age is going to be older than, let's do 40. If I run this, and age should be capitalized here. So I got a key error. If I run this again, there we go. I got, at least, I grabbed the head, which means just the first couple of people, of players with age over 40. And I was able to do that just by looking at some of the pandas documentation and learning about filtering. So I want you to explore this. It's not too long. And try out different data manipulation techniques so that you get familiar with pandas. Again, you don't need to memorize this. Often, you usually will just look at the documentation and grab the data that you need. In the next video, we're going to try and solve an interesting problem with this data set. I'll see you in the next one. Bye-bye. Welcome back. In the previous video, we learned about importing the data and using the pandas library to manipulate our data frame. Now, let's learn a little bit more about this step, which is to clean the data. And in this case, let's try to solve an interesting problem. Let's say that instead of this filtering, what we want to do, or what our boss comes and tells us, is that he or she wants to know, well, what players are a good deal? What players are the best in terms of skill, but are also lower salary, so maybe we can afford them better. So let's say that the boss wants a few things from you. If we go back to Kaggle here and look at our data, it'll actually have a link to all the columns that this data has. And let's say our boss wants to find out the current market value of the player and the wage. So he or she wants to know which player is undervalued right now, and maybe we can grab that player for a really good deal. So what we want to grab from the data is the value, the wage, and obviously the name category of the player. Now, if you want, you can pause the video and try to do this yourself. Otherwise, let's give it a go. Let's create a new variable called a dataframe1. And this is going to grab, using the pandas library, the data frame method, which will accept our previous data frame that we've grabbed, which is our entire CSV file. So let's say data frame. And then we're going to select as our second parameter the columns that we want. In this case, we can give it an array of columns that we want, which will be name, wage, and then finally value. So let's just print df1 to see if this is working. There you go. Just like that, we have the name, wage, and value of the player. Holy moly, Messi has quite a high wage. That's a nice wage. All right, let's keep going. Now here's the next part. We have this table, but the data doesn't really mean anything to us right now. Let's say we want to sort the data now. Because what we want to do is we want to compare each player's wage with the value and have perhaps a different column called the difference to see which player has the biggest gap between their wage and their value. Well, let's try and give this a go. Now, ideally, we can just create a different column by simply saying df1, we're going to add difference. And this difference column is simply going to equal the data frame that we have below over here. And it's going to be the value minus df1, the wage, just like that. Now, if I run this, let's do df1 and click run. I get an error. If I scroll all the way down, I see unsupported operand type S for minus. So I'm trying to subtract a string and a string. And we've learned about this before, right? You can see over here that the wage of a player is in euros, and they get paid a lot. So sometimes you have the M, which is for million, or K for the thousands. So we need to convert this into an int, right? So we can do that quite easily, again, using Python. Now with this part, you can try and solve this yourself and try to convert these values and wages to an integer and remove the euro sign and the M or the K for the thousands. Or if you want to just do this quickly, you can even Google around, because this is a common problem. All you do is Google for pandas, convert string to int, or in my case, look at that. Googling around, I found convert the string 2.90K to this in pandas data frame. So it looks like they are asking the exact same questions that we have. And again, as a developer, you have to really learn to start Googling and finding answers on your own, because most likely other people have the same questions you have. Now, if I scroll to the answer here, you see that I get some answers that look overly complicated, but I really like this one. So value to float. So we're changing a value to a float. We give it some sort of an X, and that's it. So this converts our value to float, and you see here that it replaces different things for us, such as the K, M, and the B. So that's perfect. Let's copy this. And again, I'll link to this resource so you can take a look for yourself. If I go to our soccer, let's enter the function that we have here. Make sure that it's formatted properly. So we now have the value to float function, which is great. If we go back to the question here, unfortunately, they only remove the last item in the list and not the beginning portion. So we can just do that ourselves because we want to remove the euro sign as well. So there's actually a pretty easy way of doing this using regex. So let me show you. We can do a wage variable that equals df1, our data frame. We're going to grab the wage column. Let's make this a little bit bigger so you can see. And this wage column is going to be replaced. And the replace method allows us to use regex. So what we can do is we'll say that we want to remove the euro sign. So let's just copy it from here. Just like this, with an empty string. And then the third parameter is to just say regex equals to true. Now, if we go to regex101.com and we copy what we just did, so let's just copy this. If I do anything with a euro sign, you see that it is highlighted over here. That's what the regex does. Again, this is something that I just experimented with. Trust me, I don't remember this off the top of my head. I just looked it up before this video. So we replace all the euro signs with the empty string. And then finally, if we go to our Stack Overflow answer, you remember here that in order for us to use the value to float, we just simply do dot apply value to float. So again, if we go to our soccer, we'll just say dot apply value to float, which is what we have up here. And we can just do the same thing for the value as well. So let's say value is going to equal value here, and the same thing being applied. And then finally, with these new columns, we can just update them by simply saying df1 wage is going to equal wage. And then data frame 1 value is going to equal value. So because now these are going to be integers, I can now run this minus operation, and hopefully, if we didn't make any mistakes, this should work. Let's have a look. All right, look at that. We have a new difference column, which just subtracts value from wage. Awesome. The last thing I want to do is to actually sort this so I can better understand it. So let's do, for the last part, say sort values. Again, another thing that we get from pandas. And we'll sort by the difference column. And we'll say ascending equals to false. So we get the biggest difference first instead of lowest to highest. So if I run this now, look at that. I get the players with the biggest difference all the way down to the lowest players. Very, very cool. So this was a bit of a longer video, but I wanted to show you the idea of cleaning the data. That is, we removed any unnecessary data, we converted types or cleaned things up in case we needed anything, and then perhaps even added extra information that we might need so that we can improve or get insights about what we might want to do next. Let's take a break and I'll see you in the next video. Welcome back. We finally created some data that our boss can finally use. The difference between wage and value of a soccer player. But this is kind of hard to read. Wouldn't it be nice if we can visualize this data? And that is a big thing that a data scientist does. It analyzes the data, understands the data, cleans the data. But at the end of the day, if you want to present this to anybody, you need it in a format that is easily understandable for somebody that might not be a data science expert. So let's visualize this. Now, we talked about matplotlib, which is what is often used to visualize this data. Now, this library is very extensive, and you can read the documentation on your own. But a ton of other libraries have been built on top of it to simplify and make it easier for us to visualize data. One of these libraries is called Seaborn, and is really, really easy to use. Let me show you. So we have this data. If we go to a new cell block, and just a reminder here, the way Jupyter Notebooks works is that it has to run all these inputs. If you refresh Jupyter Notebooks and you have a notebook and just click on run for one cell, it won't have the previous cells in memory. So you have to make sure that all these cells are run in order for you to execute this part. Because if you just restarted Jupyter Notebooks, it won't have any of this in memory. But anyway, just wanted to make that note in case you have an error. Let's use Seaborn to visualize the data we have above. So again, Seaborn, you can just read the documentation, and there's tons of tutorials online that you can follow. But I'll just show you the easy way of doing it. So we're going to import Seaborn. We're going to set up Seaborn by just running set. And now we can just create a variable, graph, and call SNS, or sorry, I should do Seaborn as SNS, just so we don't have to write Seaborn every time. So SNS.set. And then we're going to say graph equals SNS, and we're going to use the scatter plot as the graphing method that we want to use. And on the x-axis, we're going to use the wage. And on the y-axis, we're going to use the value. And the data we're going to use for the graph is going to be data frame 1, which is what we have up here. So if I run this, all right, we should have the graph now. So let's actually print it out. If I click run, look at that. How easy was that? Seaborn was imported for me. And all I had to do is say what graph I wanted, what were the values, so that is the x-axis and the y-axis, and what data we want to use, and all of a sudden I have a graph. How cool is that? Just like that, using some really nice Python libraries, I now have a notebook that shows my progress of exploring this data. But we have one problem here. You see, I have all these scattered dots, but I don't really know what they mean. Wouldn't it be cool if there's a way for us to hover and actually see which player represents the dot? Well, we can do that with another library. And this one is called Bokeh. It's a hard one to say. Bokeh, whatever you want to call it, is another library that allows us to actually have interactive visualizations. So again, if I go back, I can use it in a similar fashion that I did with Seaborn. I simply say from Bokeh, this is going to be really hard to say, and I'm going to say dot plotting. So from the plotting library, I'm going to import the figure and show functions. And then also from the bokeh.models, I'm going to import the hover tool, which is going to allow us to hover over these things. Again, you don't have to memorize these. If you go to the documentation and look at the quick start, you'll actually see this, or you can even Google for it. So if we actually go to the quick start guide, you see that we have the two libraries that we imported, plotting and models, and it shows you how to get started quickly. As a matter of fact, we can just copy and paste this line, which allows us to plot title and x-axis. So let's do that. And I'm going to give the title as Soccer 2019. The x-axis label will be wage, and the y-axis label will be value. And in here, I can give it different parameters that perhaps I want. For example, I can say plot width for how many pixels I want my plot width to be, and same with plot height. We'll say we want that to be also 700 pixels. And then finally, I can say what type of tools I want to use. In our case, we're going to create a hover tool so that we can hover over this figure. So this will be our graph right now. Next, if I do p.show, or actually the way it would work is we do the show that we import from here, and we run it like this. And you know what, for now, let's not use any of the hover tools. If I click run here, looks like I have a bit of a mistake here. I deleted show by mistake. Let's click run. And look at that. It actually opens up a new HTML file for me so that this could be interactive. But right now it's empty. We actually have to draw the circles of our plot. But we have wage and value. And the title, Soccer 2019. If we go to the quick start, we see that we can do lines, And we can do circles as well with different type of options. And because we're doing a scatter plot, let's do exactly that. I'll go back and in here, say that I want the circles that we're going to create. And again, don't get too confused if this is new to you. Again, this is all just a library and the documentation that you have to read if you want to get familiar with it. So we'll have the circles, wage and value. So that is the x-axis and the y-axis values of the circles. And then we'll say size. We can give it a size of, let's say, 10 for now. And the source of the data will be from df1. So that's what we want the circles to contain. If I now run this, I may have spelled something wrong. This should be size. If I click run, look at that. I have my data points, which is great, which is what we had before. We have a new HTML file that's generated, but I want to be able to hover. So if I go to, let's close this for now. If I go to the quick start guide and let's just search for hover, we see that we have the hover tool. And we have all these options that we can use for hovering again. Oh, I like this one. But I'll just show you the basic syntax. Essentially, what we want to do is we use the hover to equal the hover tool that we're importing. And in here, we can say that the tool tips is going to equal a list that contains some tuples. So it looks like we can use the tooltip like this. So let me just copy this. So we have the tooltips, we have the index, and then the X and Y axis. In our case, it's wage and value. And we'll change this to wage and value. And we don't care about the ordering, but we actually want to add another field, which is the name of the player from the data. So as you can see, in the hover tooltips section, or for basic tooltips, it'll show you exactly what each value represents and how you can represent it. And you have the dollar signs and the @ signs. So in our case, we want to individually have the wage and the value displayed here. So we're going to use the @ sign, unlike the X and Y dollar sign, which just simply gives us the X and Y value. So I'm just going to change this to the @ sign, and then finally also have the name property as well. Now the final thing we need to do is to just give this tooltips as the tools inside of this figure parameter. If I now run this, it looks like another error. Let's see. So it should be hover tool here. And give it the array that we want. So that if I run, hey, look at that. We have an interactive plot that we can actually analyze. So we see here that Neymar has a pretty low wage compared to his value. What about Messi here? Well, Messi is definitely getting paid a lot compared to his value. So you might find some good deals for trades, maybe with Mbappe. Very, very cool. Now, this is just the tip of the iceberg. When it comes to visualization libraries like this, there's a lot of trial and error and learning how the library works, how to visualize this properly. And up until now, all we've done is this part, right? We've imported the data and then cleaned the data and maybe have done some visualizations with it. We haven't really done any of these parts yet. Up until now, what we've been doing is mostly data science, trying to grab data and understand it for business purposes. I want you to explore this data set a little bit more, maybe try out some of these data visualization libraries. But for now, I think we have enough to move on and get into some more machine learning concepts. I'll see you in the next one. Bye-bye. Welcome back. That last project was a little bit overwhelming because we used a ton of libraries and a lot of data visualizations that are very specific to a library. But we haven't really touched the topic of training the data and creating models. So in this project, we're actually going to do some machine learning. It's going to be a lot of fun. But I want to give you a warning. This is just a taste of what machine learning is like. If this is your first time, it might seem a little bit overwhelming. But just like with anything, it's all about practice and repetition. But hopefully, by the end of it, you will see the 6-step process and how it actually works. And at the end of the day, you'll also realize that it's not maybe as complicated as you might have initially thought. So let's get started. The first thing we're going to do is create a new notebook with Python 3. Now, this time around, we're going to use a different data set and a famous one when it comes to machine learning. It's called the iris dataset for the iris flower. So if I type in iris flower, it's a dataset that has all this information about the iris flower that actually has different types. So we're going to create a machine learning model that can detect types of the iris plant. Now, luckily for us, we can access this data very, very easily using scikit-learn. Scikit-learn, if you remember, was another library that is really, really powerful to help us with machine learning. So all we have to do is say from scikit-learn dot datasets, and scikit-learn comes pre-built with some good datasets that you can explore on your own. And we're just going to import the iris dataset, or lowercase I, just like this. So that if I do iris equals load.iris, just like this, and I click run, and this should be an underscore. So we now have the data loaded. And if we go back to our REPL, we've imported the data. We don't need to clean the data. We learned about that in the previous project, but because scikit-learn has these data sets pre-built, we can assume that it's clean data that we can use in our models. The next step is to split the data into training set and test set. But in order for us to do that, we can use this concept of X and Y in machine learning. So X, this capital X, usually means the inputs that we want to give to our machine learning model. So in our case, we'll say iris.data will be our inputs. So that is the data that we get. So let's actually see what that is. Let's run. That's the data. You see that it's just some massive arrays. And Y is going to be the target. So if I do .target and I click run, you'll see that this is the target. Now, what this means is we want to find or create a function that takes in X, which will be our data, and outputs the Y, which is the target, that is the answer. Now, in our case, these are the answers, 0, 1, and 2. But if I Google iris dataset, and I go to the Wikipedia page here, you'll see that there are 3 types of iris: the setosa, versicolor, and virginica. And each one of these is represented by either 0, 1, or 2. So if we look at our data set, this target is the types of those 3 iris flower types. So the target in this case that comes preset with the scikit-learn library is this is the data of the images. So again, if I remove this and hit run, this is the image. So each list is a piece of data that represents by some parameters the iris flower. And then we have the target, which is the answer, is when we input this data, what is the output? Which one of the three flowers is it? Now, if I go to Kaggle and I actually type in the iris dataset, you can see that the columns are, well, the length of the petal, the sepal length, and then the species name. So you can see here that these are the columns that it's testing for. And you can see these are the numbers that we get in that array, and each one corresponds with different type of the iris flower. So let's get back to that. I'm going to say that capital X is going to be our data, our input. And then Y, lowercase y, and this is just a standard, will be our target. Finally, we actually want to get the feature name, so each item in the list here is a feature. Remember, that's what these columns are. These columns are the width, the length of the petal, and the sepal. So we can store that by simply saying feature names as the iris dot feature names, again, which comes pre-built with the iris dataset. And then the target names will be the iris dot target names. Again, if I run this, let's do feature names first. There's the columns. And if I do target names, you see that these are the three options. So up until now, we've imported the data. We didn't have to clean the data. We haven't really split the data yet, but we're at least starting to understand our data and perhaps what it contains. So once we've understood the data, and knowing that we have this information, we can now start splitting the data into a training and data set. Because right now we're doing supervised learning because these are labeled, right? We have all the data that we need, and we also have the answers that we need so we can test our model. By the way, before I show you how to split the data, what do you think the type of X is? Can you guess? It's a NumPy array. Remember that library NumPy that I told you allows us to use multi-dimensional arrays? Well, underneath the hood, this dataset is a NumPy array. It's a little bit more feature-rich than just a Python list. Anyway, let's start to split our data. So what we want to do here is from the scikit-learn library, I want to grab the model selection. And in here, we're going to import the train test split. Now, what is that? Let's Google and find out. So again, if I go to the library documentation, you can see that the train test split simply splits array or matrices into random train and test subsets. So it just randomly decides for us how it's going to split the data into the training data and the test data. So now we can use it in an interesting way. We can simply say X is the training data set, the X test dataset, the y train dataset, and then the y test dataset. And again, we can just assign that to variables by using the train test split function that we import and give it the x, the y, and some different variables. So for example, over here, if you can see, we have things like test size or random state or shuffle, different variables that we want. Again, you can read this on your own. In our case, let's just say that the test size will be 0.4. Now, let's have a look at what kind of data we have now. So if I do print x the train data, and we can do dot shape here, and we'll also print the test shape. If I run this, it returns what we call a dimensionality of the array. So that is how many rows and columns. So it's got 4 columns and 90 rows. So our train data has 90 rows and our test data has 60 rows. If I change the test size here to 0.5 and I click run, you see that now I'm splitting the test size between 50% being for train, 50 for test. So we can actually change things up and try different things and manipulate the train and test data size. Ideally, though, we want to have more train data than tests, just because remember, the more data we have, the better our model is going to get. And this is going to be the same for the yTrain and the yTest variables as well. Congratulations, we've just split the data into training set and test set. We now have some exciting steps ahead, such as creating the model. Let's take a break and learn how to do that in the next video. Welcome back. We're now getting to the exciting step of creating a model. How can we do this? Well, we've split our data now, and luckily for us, scikit-learn comes pre-built with some tools for us to use to actually build this model. So what we can do is actually import from scikit-learn different types of algorithms that we can use to create our model. In our case, we're going to use the k-neighbors classifier. But just to show you, if I go to scikit-learn models or model selection, you see that we have a ton of different types of things that we can do. We're going to use the nearest neighbors, which is a very standard, easy to use algorithm. And I'll link to some resources so you can learn more about it. And specifically do the nearest neighbor classification, which is going to do exactly this. It's going to try and divide up the data into different segments. But as you can see here, we have so many models to pick from, or so many algorithms to pick from. And one of the jobs of a machine learning engineer is to actually figure out which algorithm to use. But again, this isn't a full machine learning course, so let's just use the neighbors module. And from there, import the k-neighbors classifier. Hopefully I spelled that right. Now the way the k-nearest neighbor classifier works is we can just use it as a function, and all we have to give it is how many neighbors we want. That is, how many classifications do we want? In our case, we know that there's 3 types of iris flowers, so all I'm going to do is give it the parameter n neighbors of equal to 3. And then finally, we're going to try and fit this data and use this algorithm by giving it the train dataset and the yTrain output. So that if I run this, Well, nothing comes out of it. Hopefully, we've created our model, but there's no way for us to test it, right? If we go back to our steps, we need to check the output, right? We've created the model. Yes, it's as simple as what we just did, but we now need to check to see how good our model is. How good is our function? Well, we can use the predict now to predict and try out our tests. So we can use the X test dataset and give it to the Y underscore predict variable, which will be our predictions. So what the model predicts based on this new input X test data. Now, the cool thing that we can do now is to actually compare the output of Y predictions that our model created with the actual answers. Because remember, we created 4 different data sets, right? We created the train data sets for X and Y, and also the test data sets. So for the X test, we gave our new model the test data, which we have the answers to, and the model predicted, so this function was run to try and predict what type of flower might be based on, remember, the columns that we gave it. And now we have our predictions. So we need to compare the predictions with the Y test variable. And again, scikit-learn to the rescue has a nice tool for us to do that. All we need to do is from scikit-learn import metrics. And we can now print the actual accuracy of our model. And all we do is say metrics dot accuracy, make sure I spell that right, accuracy score. And the function takes the Y test data, which is the correct answers, and the Y underscore predict, which is the predictions that our model made. So if I run this, I get an error because I haven't run the block with the Y predict variable being created. So let's do that and then run this. And there we go. That's our accuracy. Metrics.accuracy score tells us that it's 96% correct. That's pretty amazing. Our model, which we just created in, honestly, 3 lines of code, is 96% accurate. How cool is that? So if we go over what we just did, we imported the data, we split the data into training and test set, we created a model by using the k-nearest classifier in scikit-learn, we checked the output using the Y prediction and Y test variables, and now we got the output. So now we can improve, if we want, our machine learning algorithm. So let's do that in the next video. We've just created our model. Remember, a function that gives us the desired output. And right now we want to improve on our model. So how can we do that? Well, there's a few things, right? If you remember, all we've done is split our data into test and train. But one of the things we can do as a machine learning engineer is decide how much data to give it to train. For example, if I decided that I want 80% of the data to be the test data and only 20% to be the shape or the train data, that is, the model will have less data to learn from. If I hit run here, and then let's run the rest of the blocks, and then finally this one, you see that my accuracy went down because I'm testing less data. That's not very good, is it? But what if we just give it less data to test? What happens then? If I click run on all of these and run here, I get 100% accuracy. Does that mean that this is the best option? Well, not really, right? Because what happens now is that our test size it's super, super small. We only have 15 inputs that we're testing. And yeah, we got 100% because we're learning from 135 data entries. But because our test data is so small, although we got 15 out of 15, we can't be certain that our model is that accurate because, well, we only tested it 15 times. So this is a trade-off of how much data do you want to train it with and how much data do you want to test it with. And that's why companies really value data. The more data we have, the more we can train our models. Okay, what else can we do to improve this? Well, another thing we can do is with the parameters in here of the k-nearest neighbors classifier is to perhaps do 4. If I hit run here and run again, all right, our accuracy is a little bit lower now. Because we're only testing for 3 types, 3 classes, ideally we match that with our nearest neighbors. Instead, if I do 4, what it actually does, if we go to our nearest neighbors classifier, it's creating 4 segments for us to evaluate, when instead we only need the 3 iris flower types. So let's keep that to 3. What other things can we do? Well, another thing, if we can collect more data, is to perhaps have more columns or parameters. These are sometimes called features. And the more features that a machine has to look at, the more information it can have. That doesn't mean that the more features, the better, but it does mean that maybe if there was another feature that we can look at for the flowers, there's a better model that we can build to predict what type it is. So that's another way to improve it. Finally, the most interesting part is the actual algorithm that we use. In this case, we used k-neighbors classifier, which I just told you that we're going to use. But we can use any type of algorithm we want. If we go to the scikit-learn library, there's different things that we can do. For example, we can do a decision tree if we want to, and use a decision tree classifier. So how can we do that? Well, I simply import something different. I can import the decision tree classifier, and instead of the k-neighbors classifier, we now use the decision tree classifier, which we don't need to give it any parameters. And if I now run this, oops, I have to change this to tree. So if I run this and we run our accuracy test, all right, I get 9.33. Pretty much the same as we had before. And if we change this to 50, let's run this one more time. 0.92. But if you remember, when we had the neighbors classifier with the same parameters of test size of 0.2, our accuracy was actually better. This time around, we got 100% accuracy. And you'll notice that this constantly shifts. As we train our model, sometimes it gets it right, sometimes it doesn't, because it's constantly learning. But you see that the accuracy with the k-neighbors classifier is a little bit better. So this way, we are able to improve our model so that we can now perhaps try these steps all over again until our model is perfect enough, or at least close to perfect enough for us to make business decisions. Very, very cool, right? Let's do a few more things in the next video. Let's say that we've created our model now. We have our knn.predict function that we can now run whenever we want to perhaps use. Let's say a user inputs a whole new photo that we haven't seen before of an iris flower, and we want to predict what that flower type is. How can we do that? Well, let's create a new variable here. Let's say sample equals, and create our own sample data. If we go to our data over here, we see that the data set over here has 1, 2, 3, 4 parameters. So this is an array that contains 5.1, then 3.5, 1.4, and 0.2. So let's just enter some numbers here. Let's say that here we have 3, then 5, then 4, then 2. And then the second image has a parameter of 2 and 3 and 5 and 4. So that's our sample data. We can now give our KNN predict function, which is our model, the sample data. So let's say that's going to equal the predictions variable. And let's just do something neat with some list comprehension here. We'll say that the predict species is going to equal the iris.target names p for p, which is the variable that we create in the predictions. So I'm just using a little nice shorthand Python syntax to hopefully give us the prediction answers. So let's say print, and then our predictions is going to be the predict species. So that if I run this, oops, what did I mess up here? Target names, not target names, target names. Let's run that again. There you go. These are my predictions. So the first one is versicolor. The second one was predicted to be virginica. Well, it's hard to say if it's right or wrong, right? That's why we have a test data set so that we know the answer to these questions. Ideally, we have a human label these so that we can test and see if this was right or wrong. Right now, we don't know if it's right or wrong, but at least we know that it's making predictions, and it's making predictions at a 96% accuracy based on our y-test data. Very, very cool. Now, what we've learned up until now, at the end of the day, all it did was create that function that our machine can use and predict any future input. And there's many applications of this, right? We now have a function that as a programmer or a developer, you can use throughout your code bases, maybe on a website, maybe on a robot, to try and receive inputs and predict something. Whether that image is an image of a snake, maybe a user sends an image that is not safe for work, well, maybe that predict model can predict and see if it should be uploaded or it shouldn't. But there's a problem here. You see, right now, we don't have that much data because we've only used a data set that has 150 rows. But in real life, to train a really complicated model, you have millions and millions of rows. And this function of fitting and running the kn.fit takes a really long time. And most of the time, you're running these types of operations on something like a GPU or a graphical processing unit. And sometimes in the cloud, because you wouldn't be able to do it on a regular computer. Now, this part is very, very time consuming. So you wouldn't want every user that submits an image of a snake to actually run this function. We call this model persistence. And model persistence is important because next time we want to make a prediction, we want to save this model, this function, to a file and use that file for predictions. When you're on your iPhone and you're using, let's say, a machine learning feature, it's not going to run and train the model right there. Ideally, that model's already there on your phone. And this idea of model persistence is important. So let me show you how to do that. Once again, scikit-learn to the rescue. With scikit-learn, I can say from scikit-learn import job lib. Now I can save my model using the job lib module by simply doing job lib.dump and dump the model somewhere. So we're going to dump the K and N, which is our model. So we're going to dump K and N, and we can call it whatever you want. Let's say mlbrain.joblib. That's the extension that we're going to have to use since we're using the job lib module. And this stores the trained model in a file called a binary file. So if I run this, and I get an error. And that is because we have to do scikit-learn.externals. So this is just a way for us to import the joblib module. So if I run this again, there we go. If I now go to my Jupyter notebook, you can see that I have a joblib file. So now, in the future, instead of me retraining the model, I can just simply do job or model, since we assigned it to a variable, and say model equals job lib. Actually, we don't even need the equal sign here. We can just dump this. So let's just run that. And we can just assign it now to the model whenever we need it. Say model equals job lib.load and load the name of the job lib that we want, which is the mlbrain. So now if I do model.predict on the, let's say, the X test data, and I click run, look at that. I get my predictions. And if I now copy the code, which was the sample data over here, so let's just cut that out and paste it in here. If I click run, there we go. Our model, and instead of predict, we'll just do model.predict. If I click run, look at that. This still works. So I was able to save my model so that I don't have to keep training it, because that requires a lot of power, so that my user, whenever a user wants to use my model, they just simply use the joblib load to load it up and then use the predict method. And this is how models work in real life. And anytime we make an improvement to the model, we simply just dump it again, maybe to a user's phone, so that they can use it. But this way, only the business owners that have a lot of compute power can train the models as they get more and more complex. Holy moly, we did it. That wasn't too bad, was it? I mean, there's a lot of new concepts. And machine learning is a big, big topic that could be a whole course in its own. But I hope I was able to narrow down the essence of machine learning so you understand what's happening when people talk about ML. We're simply doing these steps. And we've learned about all of these steps so that now you can start to improve on them and learn how to perhaps improve at each step of the way. Now, I've created a little notebook here that you can actually follow. I even have done some visualizations for you here using matplotlib to show you some of the iris dataset and kind of explore it on your own. But the key here is that you use Jupyter Notebooks to visualize data, to manipulate data, to clean data. And then slowly, as you start to learn about your data, you start making predictions to test your data, to train your model on this data set, and hopefully get it to the point where you can make some important business decisions. Now, this iris dataset isn't necessarily useful to somebody like Amazon or Google. But using these basic principles, you now have the ability to increase the ability of a model from just detecting flower types to detecting all sorts of images. image recognitions. Self-driving cars all use the same principles. But at the end of the day, all we're doing is creating these models or functions by giving them inputs and some of our outputs to see how good we can create that function. And all we're doing is moving ourselves away from the function writers to simply the data aggregators and the people that change the inputs here and there to try and make the function as good as possible. Now, the topic of machine learning is really, really vast. There's different topics that we can explore, but the key thing is that there are a lot of tools. And in order for you to do machine learning really well, you need big data sets. So companies that we talked about, like Microsoft, Amazon, Netflix, can do machine learning really well and invest a lot of money into machine learning because they have these data sets available. Now, you can create your custom models, but these big companies also offer things like retrainable models. That is, very general models like Vision, AutoML Vision, that you can train, but they initially at least have created the base model for you. Or you can even use the pre-trained models, which essentially do everything for you. It's that model that you can just plug and play and use, and you get the benefit of all that data that Google collected. They just give you the model that you want to use. You want to do translation? Well, you just send them the text and they'll respond with the translated text for you. Because remember what I said, the value is not necessarily in the model, but in the data that we use in creating that model. This was a big topic. I hope your head doesn't hurt. And if you don't get everything 100%, don't worry. This is a big topic that is constantly evolving. And there are so many advances happening every single day that even the experts are overwhelmed. The idea of this section was just to introduce you to the topic so that maybe if this piqued your interest, you can explore these topics on your own further along. I'll leave some resources, some of my favorite resources for you so that you can explore this a little bit further. But for now, good job getting this far. I'm really proud of you. I'll see you in the next one. Bye-bye. Our final project in the course, and I want us to have a little bit of fun. This one is going to be nice and quick, but also a ton of fun that hopefully gets you excited about the power of machine learning. Now, my personal opinion is that most of the machine learning moving forward is not about creating our own models or doing really complex math and statistics, but instead it's in the ability of us to use pre-existing models to solve business problems, to solve human problems. And I want to demonstrate this by using a great library called Image AI. And as you can see here, let's make this a little bit bigger. It's a Python library built to empower a developer to build applications and systems with self-contained computer vision capabilities. That is, instead of us having to build a computer vision model all from scratch, we can use pre-existing tools to use something like this library to solve a problem or maybe create an entire business around a model that is freely accessible to us. And I'm going to show you this awesome library that's going to do some really neat things. So I'm going to link to this resource, but what we're going to do is we're going to create an image recognition app where we feed it some photos and it's going to be able to tell us exactly what that image has. That's pretty cool, right? Let's get started. So if we read through the documentation, it actually has a pretty good overview of what we can do. Now, as you can see here, we have to install a few things for us. So let's just copy this and I'll go over what some of these do. So we're just going to copy and paste. Make sure that you're using pip version 3 based on your installation. We're using TensorFlow and Keras and OpenCV, which is an image processing library. And TensorFlow and Keras are very popular machine learning libraries. Now, we're going to install this. And as this is being installed, it's quite a bit to install, so just a heads up that these libraries tend to be heavier. And then we also want to install the Image AI library. So let's copy this, and let's see if this is done. Nope, it's still going. Give it a bit of time. Let's clear this and run the Image AI upgrade. All right, so hopefully we have these libraries installed. And what we can do is, well, just simple image prediction. So I've created a folder here, Really Smart Brain, that has an empty Python file and 3 images that I'll attach to this lesson. We have a giraffe image, a Godzilla image, and a house image. So let's see how we can use the Image AI library. What we can do is say from Image AI, we're going to use the prediction module, and we're going to import the image prediction part of it. Now we also want to grab these files, so I'll just do a simple import of the OS library so that I can say execution path will equal the OS dot get current working directory. That is, wherever I'm running this from, get whatever directory we're in. So that's just saying present working directory. It'll grab this directory for us. So that's the execution path. And we can instantiate the prediction, image prediction that we just imported by saying image. Oh, and this should be capital I. Let's make this a little bit bigger. So I'm going to say image prediction to instantiate it. And in here, we can do some different things. If we go back to the library, we're using the image prediction option here. Keep in mind that this library actually can do different things like object detection, which is really, really cool, or video object detection. But for now, we're interested in the image prediction. So if we go to tutorial and guide, you'll see exactly here what we can do to do the predictions. So let's just copy this for now and go over what it does line by line. We have our prediction variable, and we set the model type. That is, we decide what model we want to use. Now, this library has a few models that we can use. And these are really popular models that are already pre-built. For example, Google Brain Team has this model that's created. The Facebook AI Research created this model for image processing, and then ResNet, a very famous model by Microsoft. Now, we'll use the SqueezeNet because, as you can see, the size of the model is quite small compared to the other ones. That is the downside of these models. Sometimes they can be heavy, but the smaller the algorithm, the faster the prediction time, but the less the accuracy. So instead of using the ResNet, let's use SqueezeNet. So I'm going to change this to SqueezeNet. Next is to set the model path. So again, we're using the OS to find the model that we want to use. We actually have to download these models if we want to use them. So you can see here, if I click on it, I get a little download of the SqueezeNet. So again, the more accurate ones will just have more bytes of data that you have to download. So it's up to you. I'm going to use the SqueezeNet though. So now I get this file, which I can move into my project folder. So let's go to desktop, go to Really Smart Brain, and then plug it in here. So again, this is a binary file that we can just use as our model. I'm just going to copy the file path or the name. so that instead of the ResNet, we'll use the SqueezeNet model. Awesome. And then finally, we want to load the model and then make some predictions. If we go back to the documentation, we can make the predictions by copying this piece of code. We see that we have the predictions and the probabilities, that is how confident the model is in its prediction. And we're simply saying, hey, predict image. Let's make this a little bit smaller. Predict image, and we're going to give it the image that we want to test. In our case, instead of 1.jpg, we'll say giraffe. So let's say giraffe.jpg, and we'll keep result count at 5. And then finally, we do a for loop. So for each prediction, we're going to zip the predictions and probabilities and just print out the output that we want. Let's actually see what this does. I'm going to save this and run our brain.py. Oh, I have to say Python 3 brain.py. So we get actually the answer here, but I want to talk about the error that you might encounter. So if you see over here, I get some errors in my code. And again, this is something that depends on the machine that you're running this from. You might have different issues, but these are mostly warning based on my library versions that we've installed. Again, depending on when you're watching these videos, some of these warnings might appear to you based on, again, the TensorFlow, the OpenCV, the image AI libraries that we use, or I might even get issues with my CPU that doesn't support instructions that this binary, which is the H5 binary that we installed, does not actually support. But in the end, we still get an answer right here. Let's make this a little bit bigger. We get, it's not looking good. It looks like 28%. It thinks that this is a ruffed grouse. I don't even know what that is. Let's Google image that. A ruffed grouse. Oh, that's really funny. Look at that. So it thought that this is what the image was of, and it was 28% confident. It thought it might have been a prairie chicken. That's 10% confidence. A cheetah, a partridge. All right, so it didn't really get it right, did it? That image does look a little confusing. So unfortunately, that model wasn't accurate enough. But you can see here what the code is doing, right? The code, when we loop, says, hey, I want 5 results of your predictions, and then I want you to grab the predictions and the probabilities, the confidence that you have in these predictions. And because SqueezeNet is not necessarily the most accurate, it didn't figure out the giraffe image. But what about Godzilla? That's another tough one. Let's do the Godzilla image. If I save and run this again, let's clear. Again, we're waiting, and there we go. We have American alligator, 46% confidence. Does it look like an alligator? All right, that's not too bad, actually. We also get the common iguana for 18% confidence. All right, last one. Let's do house. If we do house here, save and hit run. Hey, look at that. We get boathouse for 58%. By the way, I also just downloaded the ResNet model, which is supposed to be a little bit more accurate. It's about 100 megabytes. So that took a bit of time, but I want to see if the accuracy improves. So I just changed set model type as ResNet and changed the path to now the new model that I have. All right, we don't need to open that. So let's give that a go. I'm going to run again. You see here that it took a little bit longer than previously because it is a bigger model. But it looks like it thinks this is either a church or a boathouse, but it's pretty sure it's a church. All right, it kind of looks like a church. What about the Godzilla image? Let's do Godzilla. See what they think of that. All right, it's super confident that it's an American alligator. All right, still not great, but what about the giraffe? Let's check out the giraffe. If I run this, oh boy, this is not that great either. So as you can see, it's hit or miss. The idea is that this is never going to be perfect, but ideally we create a model that is useful enough to derive some sort of business outcomes or positive business outcomes. Now, this was just a little taste of what you can do with Python and machine learning. The real power comes when you combine pre-built models that big companies have already built for us to use them to solve our day-to-day problems or our business problems. And that's why Python is so popular, right? It's the idea of the developer community. There are so many libraries, so many tools that are given by the community to everybody who uses Python. Python is popular because our possibilities are endless. As you saw, there's so many career opportunities, so many different projects that you can do. So I encourage you to explore this library, explore other libraries, and see how you can use Python to make your life easier. I'll see you in the next one. Bye-bye.